Okay, guys. So let's talk about 5.2 in our college algebra textbook. In this one, we're going to talk about power functions and polynomial functions, and just looking a little bit different stuff with them, making sure we fully understand. Hopefully, this is nothing brand new, so that it shouldn't be too terribly difficult for us. And I just want to make sure we understand what a power function is. So a power function would be basically any variable. So we could say x raised to a number. Right, so it's raised to a power, and that's key. And I can put anything I want in front of that. I can do 3x to the fourth. I can make it 2x to the 1/2. These are all considered power functions and basically polynomial functions. What is not is when I have a number raised to a variable. And we're going to deal with this in next couple chapters, but this is basically our exponential functions, and we're going to deal with logs and stuff like that. Where this is a fairly consistent, like this is I won't say a consistent growth, but it's not as quickly as this. This one, if we know what a log looks like or an exponential growth, it'll start off kind of slow and then it shoots up very high. Also, there's a couple different things with our domain and our range. What can this be and what can this not be? But we'll deal with that as we progress along. Don't know why I did that. So let's talk about a couple different examples. So first example would be 1. I know it sounds kind of weird, but that is technically a variable raised to a constant number. And then we just work our way up there. We got x squared, x cubed, and so on and so forth. But we also have other things, such as 1 over x. That's okay, right? That is a variable raised to a constant number. Right, what about something like square root of x? That is x to the 1/2 power. So these are all considered power functions by our definition, and this is what we're going to look at. And when we look at these, we're going to talk about them in a sense of what is our end behavior. And we deal with two kinds. We deal with x to an even, x to an odd, and in this case k, we're going to put a k right here. K must be greater than 0. But then we're going to do the same exact thing. We're going to do, I'm going to make this skinnier. I'm going to say k x even, k x odd, but in this case k is less than 0, so in this it's negative. And we just got to deal with these. What is k x to the even? Or we're going to take the idea of x squared. What does this look like? Hopefully we know what this is. That's a really ugly line. What does this look like in particular? And then we're going to deal with our end behavior. Alright, so in general, it looks like this. This is for any even. If it's x to the 4th, x to the 6th, this kind of flattens out a little bit and it starts looking more and more kind of like a half box, but it's general. And we state it. There's a couple of ways we can state this. We can say as x goes to negative infinity. So as we go to the left, f of x, or y, goes up to infinity. As x goes to infinity, f of x, again, is going to go up, goes to infinity. Now, odd. And so when we talk about odd, we think about x cubed. x to the 5th, x to the 7th, so on and so forth. Looks something like this. And as x goes to infinity, so as we go to, as negative infinity, as we go to the left, our graph goes down, meaning f of x, or y, will go to negative infinity. As x goes to positive infinity, y will go to positive infinity. It goes up. And you just trace, right? And how I tell kids to do this is, okay, I start in the middle. If I'm going to negative infinity, if I'm going to the left, my pin going up or down, in this case it's going down. And I say, well, what happens at the very, very end, because it could have squiggly lines. It goes down. Okay, that means it's going to negative infinity. As I go to the right, it's going up, so it's going to positive infinity. So that's our basic form. Now, what happens when our k is negative? So in this case, we'll say, like, what if it's negative 2x squared? All that happens is that our u flips over to an n. Like so. That's a horrible upside down parabola, but you get the gist. So now, as x goes to negative infinity, I'm going down. So it gives me f of x, or y, gives me negative infinity. As I go to the right, it goes down. Notice what happens. My y's flip. They change. So if I use that logic and do my next one, what should happen looks like this. As x goes to negative infinity, now I'm just going to flip it. F of x goes to positive infinity. And as x goes to infinity, f of x, or y, goes to negative infinity. And again, I'll say this is negative, let's say 3x, and I'll say it's the 7th power. It's an odd. Doesn't matter what it is, it's just an odd power. And so we should be able to do this no matter what it is. You know, which is it odd power, is it an even power, or my coefficients positive or negative? So now let's talk about some of the stuff that we need to be able to identify to make sure that we can do this. So we have our leading coefficient. And we have our degree. And this is what really tells us what's happening. So if I give you an example, what one of these looks like, let's say f of x is equal to, let's say, negative 4x cubed plus 2x squared plus 3. So what I do is that, okay, my degree is 3, so that means I'm looking at x cubed, right? So typically it looks like this, but my leading coefficient is negative, so I know it flips. So I know that as x goes to negative infinity, f of x goes to positive, and as x goes to positive infinity, f of x, or y, goes to negative. Now what happens if it's not in order? Right, this one was in order. It goes from the highest degree to the lowest degree. Let's say we have 7t plus 5t to the 5th minus 2t cubed. Now, you don't have to do this, but what would be easiest is you go and you put it in order from your degrees. 5t to the 5th minus 2t cubed plus 7t. Oh, this is what I'm looking at. And you could, if you don't have, I mean, if I'm only looking for my end behavior, I could just look at this and automatically say, oh, that's my highest power. So that's my degree. It doesn't matter. So this is 5t to the 5th, so it's an odd again. It looks like this, so it's the same exact thing. So as x goes to negative infinity, f of x this time goes to negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. So you do need to get them in order if you don't see it. Some people see it automatically. Some, oh, I can figure out what the degree is. No big deal. It's better safe than sorry. Just to line them up. Now, we can also state, can you determine what a polynomial could be given the graph? So I hope that you see, oh look, there's, what you do is you change, there's two different ways we can do this. How many times does it change direction? Meaning, how many peaks and valleys are there? Well, there's 2 right here, so I know that there has to be at least x cubed. Also, I could say, how many segments are there? It's basically, I have 1 segment here, 2 segments here, 3 segments here, and it gives me x cubed. My end behavior is as try this again. As x goes to negative infinity, f of x goes to negative infinity, and as x goes to infinity, f of x goes to infinity. So I know that it's a positive leading coefficient. So all we're really looking for is, what's my coefficient? Well, it's positive. And what is my degree? I know it's odd. It could be x cubed, it could be x to the 5th, it could be x to the 101st power. You don't truly know unless you get more information, but that is one way of doing it. Okay, let's look at another way of it being written. What if you were to get something like this? Negative 3x squared, x minus 1, x plus 4. Now, some people would automatically do, say, multiply this entire thing out. Perfectly fine. That's great. But if we're only looking at the end behavior and leading coefficient, I only need to multiply what my x's are. So negative 3x squared times x gives me negative 3x cubed. And then I multiply it again, it gives me negative 3x to the 4th. Okay, that's an even power. So it looks like this, but it is flipped. So it's going to be down like so. So I know that as x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x still goes to negative infinity. Now, other things that we can also determine. Okay, so can we determine what my x-intercept is? I'm sorry, what my y-intercept is? And we can. So I'm going to write a new problem. And in this case, we're going to find our x, our y, leading coefficient, and degree. So we can roughly sketch this. To find my y-intercept, I put 0 in for all of my x's. It would be negative 2 times 1 times negative 4, which would give me negative 8. Also, there's also a trick of doing it if you multiply all your constants, though there's a couple special cases of those, like for instance when there's an x out in front, you have to understand your constant 0, but putting 0 in for x works every time. Now my x-intercepts, so sorry, write this correctly, 0, negative 8 is my y-intercept. My x-intercepts, what makes each of these 0. So I say, well, x is going to be 2, x is negative 1, and x is 4. So I know my x-intercepts are 2, 0, negative 1, 0, and 4, 0. Alright, so now I just need to figure out where does it start. Multiply our x's together. X times x times x is x cubed. It's a positive leading coefficient. So I know that as a positive leading coefficient, I'm going to run out of room. Do my best. It's a positive leading coefficient that we typically, or we always, start down here and we end up here, right? Because that's an odd power with a positive coefficient. Let me get rid of this. Maybe. There we go. Now I gotta plot all my points. So first I'll do -1. Let's say that's, I'm gonna say that's right there. Then my 2, 0, and then my 4, 0. And then I need to plot 0. Oh, you know what? I want to see if y'all can. It's not -8; it's +8. And I would have figured that out really quickly, because if I were to go up from here and go here, there's no way to get negative. So this is a +8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna go down here, work my way up, come back down, and that's a rough sketch of what my graph is going to look like. Let's see if there's anything else we want to work on. Oh, okay. There is one other thing I want to talk about. So we want to, let's say I have a function like this. And we're gonna graph all this, and we want to determine how many turning points are there, how many positive, negative, even, odd. So I'm going to show you the trick that I did with my y-intercept. I didn't get to do it last time. So what I'm going to do first is I'm going to say, okay, let's first find what my degree is. In this case, it's -4x cubed. So what does that tell me? That tells me that in my graph, I'm going to start up here, and I'm going to end down here, because it's a cube and it's negative. Now, I want to do my y-intercept. Here's what's the interesting thing. So if I do my x-intercepts, what makes -4x equals 0? In this case, x is 0. If I ever have an x-intercept that's 0, then my y-intercept is also 0. So I have 0, 0 is one of my points. Then I also have, if I look here, this gives me -3, 1, 2, 3. And this gives me a +4, 1, 2, 3, 4. Start down here, go back up, go back down, and you actually put it in a calculator. It's not much smoother than that, but let's just try that again. Let's see if I can make a better line here. We're going to hit 4, so we're going to go up here, come back down, close enough, and then I'm going to finish this right here. I think that's everything you need to know for this section. Yep. So just make sure you're good with that.